Hi students, this is Mr. Yao. In the last two lessons, we have learned about the arithmetic sequence and we have learned about the recursive formula and explicit formula. So in this lesson, we're going to combine them and work on some more complicated questions. But first, let's do a quick review. Prior knowledge. Based on the sequence, write the recursive and explicit formula. So for the first one, doesn't matter if you're writing the recursive formula or the explicit formula, you are going to need to identify the a sub 1 and d. So for a sub 1 is negative 13, and d is, well, from negative 13 to negative 7 to negative 1 to 5, you're adding 6, so d is 6. Recursive formula, you have to list a sub 1 again, and then whatever term you're trying to find, which is a sub n, equals to a sub n minus 1 plus 6. The explicit formula, whichever term you're trying to get, you need the first term, and so first term, and n minus 1 of the common differences, which is 6. So we distribute the 6. So negative 13 plus 6n minus 6 simplifies to be 6n minus 19. That's A. B. Given recursive formula, find the explicit formula. So a sub 1 is already there, so d is in the recursive formula. D is negative 17. So a sub n is, first term is 73 plus n minus 1 of the common difference, which is negative 17. I suggest you put a negative 17 in parentheses and also write the little dot to indicate that you're multiplying negative 17 times n and negative 17 times negative 1. You got 73 minus 17n plus 17, which is negative 17n plus 9. There you go. Next, given the explicit formula, it's asking to find the recursive formula. So first, we need to find the first term. And this, again, is not the first term. That's not a sub 1. That's actually a sub 0. So we do need to plug in 1. So negative 12 times 1 minus 17, which is negative 29. That's the first term. And then the number in front of n, just like your slope linear equation, mx plus b, the change is in front of the variable. So negative 12 is actually the d. So let's write the second part of the formula. A sub n equals a sub n minus 1 minus 12. And that altogether is your recursive formula. Moving on, in this lesson, we're going to use what we have learned about arithmetic sequence to solve more sequence problems. Let's start with the last question from the last lesson. So here you go. Given sequence, find which term that is it's when it's asking which term is basically asking for that n number, that's the index. So what is n that will give you negative 203? So in order to find that, we're going to need to use the more official way, which is using the formula. Using the recursive formula is going to take quite a while, so we're going to need to set up the explicit formula. Let's do that. Which means we need a sub 1, which is 55, and we also need d, which is negative 6, from 55 to 49 to 43 to 37. Okay, a sub n equals 55 plus n minus 1 times the common difference, which is negative 6. Multiply that. So we got 55 plus, oh no, not plus, minus 6n. Negative 1 times negative 6 is a positive 6. So we got negative 6n plus 61. So that is whatever term is going to be, we can use negative 6n plus 61 to present it. And now, when it's asking for the index, again, that means we're looking for n that will give you negative 203. So we're going to set that equal to negative 203. And that's the equation we're going to solve to find the index n. Subtract 61 over, so negative 6n equals negative 264. And then we'll just divide both sides by negative 6. So n would be, and negative 264 divided by negative 6 is a 44. So there you go. The index is 44, which means, in other words, a sub 44 is negative 203. That's question 1. Next, example 2. Given the recursive formula, find which term is 139. Even though you're given the recursive formula, we're not going to use the recursive formula to get all the way to 139. So we're still going to need to write the explicit formula and just solve it like example 1. So a sub 1 is given, d is right here, which is 9. So let's find the explicit formula. A sub n equals first term negative 14 plus n minus 1 times the difference, which is 9. So we have negative 14 plus 9n minus 9. Simplifies to be 9n minus 23. and is asking for which term again, which again means you're finding the index. So I'm going to set 9n minus 23 equal to 139. At 23 on both sides, we got 9n equals 152. Divide both sides by a 9. That will give us n equals 18, which means a sub 18 is actually 139. There you go. That's the index. That's example 2. Moving on, example 3. This time you are given a specific term and is asking you to find the recursive formula. So let's go ahead. This time we actually don't know a sub 1. Even though you can choose to go all the way back using the recursive formula to trace back to a sub 1. But this is only giving you a sub 9. What if you're given like a sub, I don't know, a sub 90? That equals to a number. If you actually choose to subtract the d every single time, that's going to take a long time. So let's use the information we have. d is 11. Okay, if you're trying to set up the recursive formula, let me write the recursive formula on the top again. A sub n equals a sub 1 plus n minus 1 times d. So let's see. From the recursive formula, we know d, and the information is giving us a sub 9, which means we can actually use the explicit formula to set up a sub 9. So a sub 9 would be a sub 1 plus, because this is not n anymore, it's actually a 9, so that means we can actually use n as 9. This basically tells you that n now is 9. So a sub 9 would be a sub 9 equals a sub 1 plus 9 minus 1 times my d is 11. And that equals to 82. So you see we're using explicit formula because the explicit formula can represent any specific term. And if you are given a specific term, we're just going to use that to represent. So here's our equation. Let's solve it. A sub 1 plus parentheses first, 8 times 11 equals 82. And then, of course, next we need to do the multiplication. So a sub 1 plus 88 equals 82. Subtract 88 over a sub 1 equals negative 6. There you go. So that's still using the explicit formula to represent whichever term is given to you. Next, we're going to do the same thing. You're given a sub 11, which means now this n could actually just be 11. Let's put it in. A sub 11 equals, we don't know a sub 1, but we do know n is now 11, so replace it. 11 minus 1 times negative 3. And that equals to 103. So let's solve that parentheses first. A sub 1 plus 10 times negative 3 equals 203. So a sub 1 minus 30 equals 103. Add the 30 over. A sub 1 is 133. There you go. So whenever you are given a specific term, just use your explicit formula, plug that number in, replace the n, and then keep solving. Moving on, example 5. You're given a sub 14 equals negative 13, and part of the explicit formula. Same thing, we're going to do the exact same thing. You're given a sub 14, so we're going to replace n with 14. A sub 14 would be 13 plus 14 minus 1 times d. That equals to negative 13, because a sub 14 is negative 13. Let's solve that equation. 13 plus, well, you gotta deal with the parentheses first. 13d equals negative 13. Subtract the 13 over, because you're just solving equation now to find d. So 13d equals negative 26. Divide both sides by a 13. d is negative 2. There you go. So you can see example 3, 4, 5, and now 6, they're all very, very similar. Okay. Well, sorry, 6 is going to be a little bit different. So let's have a look. You're given a sub 11. You're also given a sub 20. Well, this is a bit tricky because you actually don't have you don't have the first term or the d, that means you can't actually use the explicit formula. It's actually asking for both. It's asking for the common difference and is also asking for the first term. So let's kind of set up a little table. A sub 11 is negative 67. A sub 20 is negative 112. So this is actually very similar to dealing with a slope question, because common difference is just like your slope. So we're given 11 and 20, and they're corresponding with negative 67 and negative 112. Between a sub 11 and a sub 20, there are 9 common differences. And between these two numbers, negative 112 minus negative 67 is going to be negative 112 plus a 67. That equals to 45, which in other words, 9 common difference is 45. So the common difference is actually a 5. Oh, there you go. Sorry, it's a negative 45. So when you divide, it's a negative 5. So now we found the common difference. Then it's asking to find the first term. So that means you are now given a specific term and the common difference. Then it becomes the same as example 3, 4, or 5. So we can actually set up using the explicit formula. Let's say we want to use a sub 11. A sub 11 equals, we don't know a sub 1, but we do know n is now 11 minus 1 times negative 5. That equals to negative 67. So we're solving that. Parentheses first. A sub 1 plus 10 times negative 5 equals negative 67. So a sub 1 minus 50 equals negative 67. Add it over. So a sub 1 equals negative 17. There you go. So example 6 is a little bit tricky. It has an extra thing that you have to do. You need to understand that the amount of common difference between a sub 11 and a sub 20 is 9 because 20 minus 11 is 9. And then you also do the same thing. So this is actually very similar to you doing the slope formula. This is like your x1, y1, and this is like your x2, y2. So you're actually doing y2 minus y1 over x2 minus x1, just like that. So it's actually negative 112 minus negative 67 over 20 minus 11. And that's how you would actually get the common difference, which is negative 5. So it's just like slope. And then we can do exactly what we did in previous examples to find a sub 1. So that is everything for this lesson. Thank you.